Hi everyone, I'm Hannah. Welcome to a random lecture. Today I'm going to share something exciting about statistical mechanics. So StatMech actually saved the universe from what we call a heat death. You must have noticed in life that some phenomena are just not reversible. For example, a waterfall never rises without external pump, or an ice cube can't unmelt itself when it's hot outside. It melts. Or when you are cooking, the cooked food never uncooks itself. For all these phenomena, you can blame the second law of thermodynamics. So here's how the second law of thermodynamics works. Just as there are many ways to transfer money, there are many ways to transfer energy. You could transfer energy through work. The work is the transfer of energy that's meaningful, big, macroscopic, for which people may get paid. For example, moving things, chemical reactions, writing a thesis. Another not so awesome way to transfer energy is through heat. Heat is kinda meaningless because on the receiving end, all you get is random motion of atoms. We don't get any new information out of there. However, having lived through the winters of New Jersey, I wouldn't say that heat is completely meaningless. Now, the second law of thermodynamics says that if you and I are trapped in an isolated system, and if my temperature is higher than yours, I give you a bunch of energy through heat, then you are not able to repay me that same amount of energy through work. In other words, heat can't be completely used to do work. Therefore, in that isolated system, there will be less and less meaningful things going on. And entropy, the measure of disorder, will always increase. Now, the truly scary thing is that the universe itself, by definition, has no exterior. It's an isolated system. Since the Big Bang, the entropy of the universe is ever increasing, according to the second law. That line of thought extrapolates to a heat death of the universe. Heat not in the sense of hot, but in the sense of maximum entropy, in the sense of no work. As we know, information is negative entropy. As the universe ages, it increases its entropy, it loses information. That is to say, the universe forgets things. In the end, there will be nothing meaningful left. If I have to choose a photo for the heat death, I will choose a winter photo. Because even if the name is heat, it will be a death where there's no life, no structure, no meaning at all. So, is the heat death unavoidable? Well, our hero here is statistical mechanics, founded by Ludwig Boltzmann. Boltzmann thought that the second law is not just a deterministic monster that nobody can explain. It's actually something probabilistic. It's a consequence of the statistical collective behavior of many atoms in the world. Here is an example of what this means. Suppose your atoms are 6 fair coins. We toss all of them. Here is an ordered outcome. All the coins have heads up. As we can see, the probability here of having this configuration is very low. Here is a disordered outcome. You have any 3 coins heads up, the other 3 tails up. As we can see, the probability is now much higher. So if we are looking at a random bunch of coins, it's much more likely that the configuration we see is in this order. It's a mess. Well, this explains the second law. Things seem to become more and more disordered, but it's only because there are so many ways to be in disorder that there are ways to be in order. Well, that is to say, the ordered configurations, the low entropy states, are not doomed, but just very unlikely. And surprisingly, these remarks might save the universe. Because even if those very unlikely events are unlikely in our lifetime, the universe has plenty of time to play around with, and given enough time, all miracles of low probability can happen. For example, tossing a fair coin 100 times and all end heads up is possible, or the waterfall going upwards, or in summertime, water becomes ice, or a pizza uncooks itself. All these very unlikely events might happen. That means part of the universe will fluctuate to generate a state that has lower entropy. The universe can resurrect itself from its heat death because of statistical mechanics. Besides statistical fluctuation that resurrects the universe, there are other objections of the heat death. For example, the entropy of the universe, although it sounds fascinating, is still not well defined. And even if it's well defined, the entropy of the universe may not increase but just stays constant. That also doesn't violate the second law. Also, the universe may never reach equilibrium. It's just trapped in some kinetic trap. Thank you for watching today's random lecture. To learn more, you could read this wonderful book by Katie Mack, The End of Everything, Astrophysically Speaking, or you could go to the Wikipedia page on the heat death of the universe. Thank you. See you next time.